Hello, this is Frederick Thomas with another Master Carpenter series. And what we're going to get into today is a roof, a common roof, okay? And we're going to deal with common rafters, and we're going to figure out how, I'm going to instruct you on how to frame a house with common rafters. Triangle. So what I'm going to do is show you how to get this going. And I'm going to show you via way of a calculator, okay? I think this is going to be the easiest way for a novice or a beginner, no matter if you are a beginner or if you're a master. Well, and you just need a little brush up. So the first thing we're going to do is we're going to draw a building structure. All right. We're going to draw a building structure. All right. And this is just basically the building structure here that I'm drawing. Okay. Just a simple building structure, basically a rectangle. That's all it is. We're going to find the center of this rectangle. We're going to go about right there. It's center. We'll go a little bit this way. Okay. And what we're going to do here is just draw the rafters. All right. That's the rafter length. And the apparent rafter length. That's a fascia cut or plumb cut. And here is what is called the plancher cut or the soffit cut, or plancher cut, soffit cut, or another name for it is the level cut, the plumb cut, level cut. Ugh. All right, so we're going to see how long that is. And fascia cut is, all right, we got that. And now we're going to just make it the same there. And we're going to connect this to that, so you can see the bird's mouth. A nice sized bird's mouth for this house, so you can see the bird's mouth there. The bird's mouth is that cut that you cut in the rafter. And again, this is not perfect, but it is it's basically just to give you an idea of what to do. And the reason why I'm drawing all this out, so you can see exactly all the things that I'm doing. You'll be able to determine all the calculations, so on and so forth. Let's see here. See what that is here. There's 3/8. 3/8. All right. Okay, that's the fascia. Here's the level cut. Then we'll connect that to the line there. Again, this is just a rough idea. So here we have your structure here. This center line is an imaginary line, okay? We're going to say that this structure, right, is 8 feet. All right? Half this structure, of course, is 4 feet. All right, 4 feet over here. And the same thing over here. Since the other side is the same, we're not going to figure for that. Okay? And 4 feet equals is the same as 48 inches. All right? Uh-oh. Got a lead break there. But I got another pencil in the back up here. I don't want this to get too sloppy. So you got 48 inches there. All right? And then, one thing that you have to take into account when you're making rafters is the ridge. The ridge, the thickness of the ridge has to be taken into account. All right. Now, I'm going to draw a blow up of the ridge over here. All right. I'm going to draw a blow up of the ridge so you can see a nice big size of it, and you can see what I'm doing. Exactly what I'm doing. All right. We're going to put a little X in here so you can know that we're doing the edge of a piece of wood, the end of a piece of wood. All right. So we just put an X there. Now what we're going to do is put an imaginary line straight down the center of the line. Okay. Now this imaginary line here is the same as this imaginary line. All right. This right here, the thickness of the stock of this wood is 1.5 inches. 1.5 inches. Because when you're dealing with material that's 2x4s and 2x6s, 2x8s, well, all the measurements are nominal. And it's a 2x10. We're going to make this a 2x10. So it's a 2x10. The nominal length of it is 9 1/4. All right. Now, half of 3/4 of a half of an 1.5 inches is 3/4 of an inch. Okay. So from this corner to the center line, our imaginary center line is 3/4 of an inch. And you got 3/4 of an inch on this side. All right. Now, this is important because when you are figuring your rafters, you always got to account for whatever the thickness of the ridge is. Okay. So our ridge is 1.5 inches total. Half of that is 3/4 of an inch. Why? Because the building is split in half for common rafters. It's split in half for common rafters. So what you do is you got to subtract 3/4 of an inch in order to get the proper length of your rafter. You got to subtract 3/4 of an inch from 48 and 4 feet, which is the same. So we'll deal with the feet first rather than the inches, the 48 inches. So 3/4 of an inch, or 0.75, because we're going to do decimals. 0.75, and that's 0.75 is the same as 3/4 of an inch. 0.75. Just like if you had $1 and you had 75 cents, well, 3/4 make up 75 cents. So 0.75 inches is the same as 3/4 of an inch. So what we do over here is with 4 feet, we subtract 4 feet minus 0.75. I'm going to show you how to do this on the calculator as well. It's real simple. You just put in 48 inches. 48 inches is the same as 4 feet. So put in 48 inches and then minus 0.75 equals. So our inches is going to be, let's see here. Our inches is going to be 47. 47.25. All right. And just so you know what I did here, I put in 48 inches. 48 inches minus 0.75 equals 47.25, which is 47.25. All right. We're going to work with decimals. It's a lot easier. Now, what we're going to do with that 47.25 is change it into feet. Divided by 12 inches equals 3.937 feet. All right. And 3.937 feet is the same as 47.25 inches. All right. So now that we have the run, and what I'm going to do as well is I'm going to draw another imaginary line on the other side of the ridge. Okay. For that 3/4 of an inch. So from here to here, that's that 3/4 of an inch. And on this side, the same thing. That's that 3/4 of an inch. You know, it's not exactly, but it gives you the idea. The center line is right in the center of the ridge here. Now what you do, I'm going to show you the Pythagorean Theorem. And the Pythagorean Theorem, the formula for the Pythagorean Theorem is a squared plus b squared equals c squared. C squared is what I should say. C squared. A squared plus b squared equals c squared. Let me show you how to do that on a calculator. Now, the pitch that we're going to make on this roof here, like on your blueprint, it'll tell you what pitch that you want the roof. If you don't have a blueprint and you're just winging it and you are just designing your house, well, you got to figure out a pitch that you want your roof. So for this pitch, what we're going to do is an 8/12 pitch. 8 inches of rise per 12 inches of run. That's what an 8/12 is. All right. So what we're going to do is this. We got to figure out what is the hypotenuse for this. Now, you can figure this out on a framing square. It's actually on the side of a framing square. But we're going to do it just with the calculator because it's going to be hard for me to get the frame and square. Oh, yeah. Get that frame and square. Find that blue frame and square back there somewhere. I guess I will try to show you that on the frame and square. But for now, we're going to figure out this. So a square is going to be, we're going to make 8a square. A squared. So 8 squared plus 12 squared equals. That's what we have to solve for. I'm going to show you how to do this with the calculator. The way that you do this with the calculator is like this. 8, and you press that X and that little 2, and that's your square time. 8 squared plus 12 squared equals. And then you do this, you want the square root of that, and all you do is press this symbol here, the square root symbol. And there it is, 14.42. 14.42. Now this is important. This measurement is very important here because this measurement is going to determine how long your rafter is. All right. I'm going to show you some other things that any frame and square, it should be over there somewhere. It's blue. So now that I've showed you how to do that, now I'm going to show you how to do this with the frame and square. Now, on the body of the frame and square, which is the longest part of the frame and square, what you do is you find 8, and under the 8, you have 14.42. And the top numbers, and right here, you'll know because it's a common rafter length per foot run. And yeah, so that's basically how you do it.